Law of conservation of energy. According to this law, energy cannot be created nor it will be destroyed. It can be changed from one form to another. So, according to the first law of thermodynamics, what is the equation? Delta E plus W. Q is equal to delta E plus W, or W is equal to P into delta V. So Q is equal to delta E plus P delta V. This is the mathematical expression for first law of thermodynamics, but it is used as constant pressure, right? So this is the expression for first law of thermodynamics. If we talk about at constant volume, what is the mathematical form of the first law of thermodynamics? So at constant volume, work done becomes 0, because delta V is equal to 0. Pressure can be high, low or any value, but delta V is 0, so work done is also 0. And Q is equal to delta E. At constant volume, delta V is equal to 0. Then Q is equal to delta E. Q is equal to delta E. So the amount of heat, or we can say that the amount of heat supplied to the system is equal to the change in internal energy at constant volume. At constant volume, the amount of heat supplied to the system is equal to the change in internal energy. If heat at constant volume is given, it means delta E is given. Heat at constant volume means change in internal energy. So heat at constant volume, means delta E. So this is the important thing. Now we see the enthalpy function. Actually, enthalpy is the function of temperature. Is it clear? So this equation and this equation at constant volume. So heat at constant volume is equal to delta E. Now we see the enthalpy. Enthalpy H. Basically, enthalpy is numerically equal to the H is equal to E plus PV. Internal energy plus work done. Differentiating the equation, at constant pressure delta H delta E plus P delta V. If the equation at constant volume, differentiating the equation at constant volume, then it is equal to the V delta P. Actually, differentiation of PV is P into delta V plus V into delta P. Here we use at constant pressure, so this is cancel out. It becomes 0, then it is P delta V. If we talk about at constant volume, then this is 0, then it is equal to the V delta P. So, is it clear? So, this is equation 3. Now you see the equation. 1 and 3. 1 is the mathematical form of the first law of thermodynamics. Delta H is equal to Q is equal to, this is the mathematical form of thermodynamics. Q is equal to delta E plus P delta V. It is also present at constant pressure. See here, right hand side of both equation are same. So we can say that Q is equal to delta H. Q is equal to delta H. First, combining the equation first and third, then Q is equal to delta H, and both equation are present at constant pressure. So this is the amount of heat supplied to the system is equal to the change in enthalpy or heat of reaction at constant pressure. So we can say that if heat at constant pressure is given, heat at constant pressure is given, these two things are important. Heat at constant pressure means delta H, and heat at constant volume means delta E. E can also be written as U. So heat at constant pressure delta H, heat at constant volume delta E. Clear? So in the question, if given heat at constant pressure, it means delta H is given. Heat at constant volume, it means delta E is given. Now, another relation is most important relation, and this formula is important. Another relation of enthalpy, internal energy plus delta NGRT. And from this equation we can solve the question. Here delta H, change in enthalpy or heat of reaction. R is the gas constant. Here the value of gas constant in joule or calorie. 0.0821 here is not possible because all quantity are present in energy form. 8.314 joule per Kelvin per mole, or T is the temperature in Kelvin. T is the temperature in Kelvin, and delta Ng is the number of gaseous product. Here liquid and solid are not considered. Gaseous product molecules minus number of gaseous reactant molecules. Number of gaseous product molecule minus number of gaseous reactant molecules. So this equation is most important for the calculation, and here the value of delta Ng relate the delta H and delta E also. For example, what are the conditions? Supposing that if delta Ng is equal to 0, or you can say that number of gaseous product is equal to the number of gaseous reactant molecule. If delta Ng is equal to 0, then delta H is equal to delta E, because it will be 0. Then delta H is equal to delta E. If delta Ng is equal to positive, positive means product molecule is more than the reactant molecule. In all the dissociation reaction, delta Ng is equal to positive, like PCl5 gas gave PCl3 gas plus Cl2 gas. So delta Ng is 2 minus 1. 2 minus 1 is equal to plus 1. If delta Ng positive, then it has some value. It has some value. So the value of delta H is greater than delta E. Delta H is greater than delta E. And third one is, if delta Ng is equal to negative, then delta H is less than delta E. So this is the equation. See, what are the other forms of delta H? What are the other form of delta H? Actually, this is the heat of reaction. Other forms of delta H, see here. Another form of delta H is equal to Hp minus Hr. Hp is the heat contents in reactant molecules. Heat contents in product minus heat content in reactant molecules. At which place this formula is used? What are the conditions? Main thing is, what are the conditions where we use this formula? Where we use this formula? Note down the point. Note down the important point. Note down. If all the heat of formation of all reactant and all product are given, then we can use this formula, otherwise not. Otherwise you use the Hedge law. Which we studied later. But this formula is used when heat of formation of all reactant and all products are given, and the heat of formation of standard state will be 0. Standard state will be 0, like hydrogen H2 exists in standard state, so the heat of formation is 0. O2, the heat of formation is 0. Is it clear? So when heat of formation of all reactant and all products are given, then we use this formula, otherwise not. This is the important thing. Now, what is about exothermic reaction or endothermic reaction? For exothermic reaction, these are also the important point. For exothermic reaction, Hp is less than Hr and sign H negative. For endothermic reaction, Hp is greater than Hr and sign H positive. Sign of what? Delta H. The sign of delta H is positive. So these 2 points are also important. Basically delta H is the heat of reaction. Heat of reaction is of several types. Like heat of formation, heat of combustion, heat of neutralization. These 3 heats are most important.